Hello Year 12 and welcome to the next episode of Mathematical Mowbrain Movies. Sometimes students say to me that maths is stupid or that maths is pointless. Well, I say to you today that there is nothing pointless about, there goes off the page, triangles. Got it? Nothing pointless about triangles. Who knows, maybe you got it, maybe you didn't. Anyway, today we're looking at the area of a triangle. Now you probably think to yourself, I already know how to do area of a triangle, and that's true. You do know one way to work out the area of a triangle, and that is using this formula. Area equals half the base times the height, when you've got the length of the base and you're told the perpendicular height. So you do already know that. Well, today I'd like you to meet a new formula for working out the area of a triangle. And that formula is this one here, that the area of a triangle is equal to half of A times B, again, just like in our last formulas, there's multiplications between these, times sine C. Of course, we need to know where A, B, and C are on this diagram. So just like any of our other triangles, our three sides are labelled A, B, and C. So lowercase a, lowercase b, lowercase c, doesn't matter where they are in our example here. And the angles are, of course, opposite to those sides. Now in this particular formula, there's only one angle that I'm interested in, and that is the angle C, which of course would be opposite the side that would be labelled C. So this here is my angle C. So in this formula, I'm interested in the side A, the side B, and the angle C, so this one here. So to work out the area of a triangle, what I need is two sides, and I need the angle between those two sides, which we call the included angle. So I need two sides, I'll say it again, two sides, and I need the angle between those two sides. Once I've got them, I can use this formula to work out the area of that triangle. So let's have a look at an example. Here's my example here. It says find the area of the triangle below. So you can see here that in this example I've been given two sides and the angle between those two sides. Doesn't matter which one I label A and which one I label B. I'm just going to call them A and B. This here of course is my angle C because it's between the two sides, it's the included angle. And so I can use my formula. Area equals half of A times B times sine of C. Half of, my A was 3, my B was 9, my capital C for the angle was 80. So I just whack it into my calculator there. Half, I'm just going to put 0.5 because I don't have a nice fraction button on this calculator, but you'll put the fraction of 3 times 9 times sine of 80 equals 13.29. I didn't give any units here, so I can't give any units here, but 13.29 is the area of this particular triangle. Okay, so your turn to give it a go. This is a question I want you to try. It says find the area of the triangle below. I'm giving you this triangle, but the first thing I need you to realise is that I have not given you, and I've done this on purpose, I've not given you that included angle, and you need that included angle to work out the area. So there's two steps in this question. First, work out that angle somehow, I'm not going to tell you how, then work out the area. Give it a go and good luck. Alright, let's see how you went. As I said, the first step was to work out this particular angle here. You needed to realise that you're given the other two angles, so you can work out this angle by subtracting from 180. You know that these three angles have to add up to 180, so I'm going to say, well, what's 85 plus 50? And I do it on my calculator, or I just do it in my head. 85, and I just press times. 85 plus 50, 135. So then I'm going to say, well, this has to be 180 take away 135. So again, I do 180 take away 135. So this angle here must be a 45-degree angle. Once I've got that, of course, I can work out the area because I now have two sides and the included angle here. These ones now don't make any difference to me. So my formula here is area equals half of A times B times sine C. And of course I plug my things in, doesn't matter, I'm just going to make these A and B. This of course here is my C. So I'm going to say half of A was 7, B was 14, C was 45. Half of 7 times 14 times sine 45. So again, I'm just going to use 0.5 because I don't have a nice fraction button on here, but you will use the fraction button probably. Whack it in, gives me that my area of this triangle is 34.65. So hopefully you got that one right. Here is your second question to have a go at. It says, find the area of the regular pentagon below. So good luck with that one. Alright, let's see how you went. So a few little steps in this one. First of all, you've got to recognise that this pentagon is actually made up of 5 triangles, and all of those triangles are the same. If this is a regular pentagon, and you'll see I just added that in at the end, that means that all of these lengths here must be 11 centimetres. It doesn't tell you that the ones on the outside are 11, but it tells you that these ones must all be the same. So hopefully you can start to see that I've got a triangle emerging here. Now if I want to find the area of that triangle, well, I'm going to multiply it by 5 to work out the area of the pentagon. The area of that triangle, I'm going to need the included angle here. So I say to myself, how can I work out what that included angle here is? And I need to recognise that all the way around that centre point, is 360 degrees. So all the way around is 360, and I know there's 1, 2, 3, 4, 5 equal angles there. So I divide my 360 by 5 to work out what each of those angles must be. There you go, 72 degrees. So this angle here must be 72 degrees. Now I can use my formula. Area equals half AB sine C, because I have 2 sides and the included angle. I'm going to label them AB, and this is my C here. Half times 11 times 11 times sine of my angle was 72 degrees. Whack it into my calculator. 0.5 times 11 times 11 times sine of 72, probably can't really see that, gives me 57.538, so I'm going to say 54. 57.54 is the area of one triangle, and of course there's 1, 2, 3, 4, 5 triangles, so to work out the total area of the pentagon, I'm going to do 5 lots of that. So I'll multiply my area there, by 5, gives me 287.69. So that's my area, 287.69. It's a bit tricky, and these ones are obviously a little bit tricky, trying to get you thinking. Hopefully you went all right with that one. Now, sometimes, in both of those other cases, you're working out the area. Sometimes you might be asked to not work out the area, but to work out a side, so one of these two, or you might be asked to work out that angle. On the formula sheet, you're only given this formula, so you're not given it in any kind of rearranged form. So you're going to have to be able to rearrange these ones. Thankfully, it's pretty straightforward. As you'd notice, and as we mentioned before, all of the signs between these things are multiply. So what that means is if you're trying to get any one of these things on their own, you're just going to take them over by dividing. So in this case where I'm trying to get a side on its own, doesn't matter if it's A or B, I'm just going to say A for the sake of saying one of the sides. If I want to get A on its own, I've multiplied everything by A. So if I want to take everything else over, I'm going to have to divide by everything else. So this is going to give me that the area divided by everything else, a half, and B, and sine C. You can leave those times in there if you want, or it's just a half B sine C, is going to give me my area. We usually don't like it written that way, so if I just flip it over, just so that it looks normal, then that gives us the formula for working out one of the sides. Okay, this one over here, if I'm trying to work out the angle, much the same thing. I'm trying to get sine C on its own now because I know that that's the angle. Again, I know that this is a half times A times B times sine C. So if I'm trying to leave sine C on its own, I get rid of all of this stuff that's multiplied by it, take it over, and to take it over I divide. So I'm going to get the area divided by a half AB, that's going to give me sine C on its own, equals sine C. And again, we don't normally like it written that way, so I'm going to flip it over. So it says sine C equals area over half AB. Again, these are little times's here. So that gives us two rearranged formulas, one for working out the length of a side, one for working out the angle, the size of an angle. So you're going to need to be able to rearrange that in your exam in case you need to work out one of those things. So let's now use it to give it a go. So this question here says, I'm going to leave those there so you can still see them. This question here says the area of the triangle is 30 centimetres squared, and they've asked us to calculate the size of the angle theta. So I'm going to need to use this form of my formula. So I'm just going to do the rearranging again just so that you've got it. So I write it down as it is on the formula sheet because that's what I get in my exam. I know I'm trying to work out the angle here, so I bring all this over by dividing. So my formula is half of this. If you want, you can put that in brackets to help you sort of see that you're taking all of that over, equals sine C. All right, so let's flip it around and then let's give it a go. So I need to label in my diagram what my A and my B are. Well, I know the area is the whole thing, is a 30. My A and B, I just double check, are they either side of my theta? Yes, they are. Doesn't matter which one's A and which one's B. Then I plug it into my formula. So I know that my area there that they gave me was 30, and I'm dividing by a half of, my A was 8, my B was 9. Remember, this is giving me sine C at this point. So I plug it into my calculator. 30 divided by, open brackets, you'd probably use the half, but I'm going to use 0.5, times 8 times 9, close brackets. This gives me 0.833 reoccurring. Okay? Remember, that gives me sine C. I actually just want C on its own. So to get C on its own, I have to do the opposite of sine, which is the inverse of sine. So I'm going to have to whack that into my calculator. So I take the inverse sine of my answer, and that gives me, and I'm just going to write it up here, which I know is not perfect, gives me 56.44 degrees. So I've worked out there that this angle here must be 56.44 degrees, which of course I could put in degrees and minutes or whatever if I wanted to. Okay. So you're now going to have a go at doing a similar question. So here's your question here. It says the area of the triangle below is 200 metres squared, and again you're asked to calculate the size of the angle theta. So good luck with that one. All right, let's have a look at it. Again, I'm not going to worry about doing the full rearranging this time. I'm just going to assume that you can get to the point where you've got sine C equals A over half times A times B. If you need some help rearranging, then make sure you see me because that can be the hardest part for many people. So then I've got to plug in the things that I know. I know that my area is 200, a half. My A and B, remember it doesn't matter which one's A and B, so I'm going to go 20 and 30. Whack it in. 200 divided by 0.5 times 20 times 30, close brackets. This gives me 0.66 reoccurring. Remember, that's given me sine of C. I need C on its own, so I have to do the inverse sine of 0.66. So I take the inverse sine of that answer, and that gives me 41.81 degrees. So hopefully you got that one right. Well done if you did, and maybe have another go if you didn't quite get it right. And here's your lucky last question. It's a little bit of a tricky one, of course. I'm trying to put some harder ones in for you. Sorry, that camera's a little bit, there we go. So, it says the area of the triangle below is 75 metres squared. This time it asks you to calculate the length of the sides BC and AB. So this one's asking you to calculate a length of a side, BC and AB. So you're going to need to use the one not to calculate the angle, but to calculate the length of the side. You'll also need to do a little bit of thinking about which of those sides to calculate first. So good luck and all the best. Okay, let's have a look at this question. Now, again, I know I'm given an area and I'm calculating a length, so I know I'm going to be using this formula, half AB sine C. I've got to rearrange it. I'm trying to just find A on its own, so I need to get rid of the half, the B and the sine C that are all multiplied. So my formula is going to end up being A on this side, everything else comes over with a division. So equals area over half of B sine C. I'm going to just flip it around the other way so that we've got it, and I'm going to write it in a box up here for us to just use. So we've got A equals area over half B sine C. Now, if I use this formula directly, I need to think about which of these sides it's going to calculate for me. So I've got this angle here, that's got to be my angle C, and I've got this side here, well that's going to be my side B. I've got to think about which of these two sides would be my A, and hopefully you've been able to recognise that since the angle is here and the sides have to be either side of that angle, this would be my side A, that this formula will calculate the size of. So give it a go. A equals the area over a half B sine C. Whack in my information. The area was 75 divided by a half. B was 10. Sine of 70 was my angle. Whack it into my formula. 75 divided by, open brackets, a half of 10 times sine 70. Close my brackets, gives me 15.96. So I know that this side here now is 15.96. Now this question's also asked me to calculate this side here. Now there's a few different ways that you can do it, but hopefully, and I'm going to just grab another piece of paper, this is now my triangle. Let me just draw it out for you again. Again, this is one of those situations where you have to be able to see it a step ahead and use a few of your formulas. I know that this is 70, I know that this is 10, I know that this is 15.96, and I'm trying to find this side here. Now, hopefully you can look at that and think, what rule am I going to use to work that out? It's a non-right angle triangle, so it'll be the cosine or sine rule. I'm dealing with 3 sides and 1 angle. So using your formula sheet, you should be able to recognise that this is going to be this formula here, the cosine rule. Again, that's one of the real skills, is working out which formula to use. So let's apply that formula. This is my C, of course, my capital C. This is my lowercase c, my A and my B. Let's whack it into the formula. So my A was 15.96, which I'm going to square. My B was 10, which I'm going to square. 2 times A times B times cos of my angle, which is C. Whack it into my formula. I know some of you like to square root in one go, some of you like to do it as 2 steps. Whatever you want to do is fine. I'm going to do it in 2 steps in this case, just for something different. So I'm just typing all this into my calculator. 2 times 15.96 times 10 times cos of 70. So this gives me 245.5487. Remember to leave everything in there till right at the end. This has given me C squared, and of course I just need C on its own. So I'm going to square root 245.54877. So the square root of that answer was 15.669, so I'm going to round this to 15.67. So that means that this side here is 15.67. Clearly this triangle is not drawn to scale, since that side is actually longer than this one, but you get the picture anyway. I know that's a tricky question, but these are the sorts of ones that require you to apply different formulas a couple of times. Hope you did all right with that. You're nearing the end of this topic, so well done.